Welcome to Max online class. If sin theta plus cos theta is equal to m, show that cos power 6 theta plus sin power 6 theta is equal to 4 minus 3 into m square minus 1 whole square divided by 4, where m square less than or equal to 2. Consider the LHS. Cos power 6 theta plus sin power 6 theta is equal to cos power 6 theta can be written as cos square theta whole cube plus sin power 6 theta can be written as sin square theta whole cube. Now this is the form of a cube plus b cube. A cube plus b cube. A cube plus b cube is a plus b into a square minus ab plus b square. So cos square theta whole cube plus sin square theta whole cube can be written as cos square theta plus sin square theta into cos power 4 theta minus cos square theta sin square theta plus sin power 4 theta. But we know that cos square theta plus sin square theta is 1. So remaining you have cos power 4 theta minus cos square theta sin square theta plus sin power 4 theta. But cos power 4 theta can be written as cos square theta the whole square. Cos square theta the whole square plus sin power 4 theta can be written as sin square theta the whole square. Keep this term as it is, cos square theta sin square theta. Now add and subtract 2 cos square theta sin square theta. So you have cos square theta the whole square plus sin square theta the whole square plus 2 cos square theta sin square theta minus 2 cos square theta sin square theta minus cos square theta sin square theta. Now this is the form of a square plus b square plus 2ab. A square plus b square plus 2ab. So we can write a plus b whole square. So cos square theta plus sin square theta the whole square minus 2 cos square theta sin square theta minus cos square theta sin square theta is minus 3 cos square theta sin square theta. But we know that cos square theta plus sin square theta is 1. So we can write 1 square means 1. So 1 minus 3 cos square theta sin square theta. Mark it as first equation. Now consider m is equal to sin theta plus cos theta. That is given the question. Squaring on both sides. So you have m square is equal to sin theta plus cos theta the whole square. Sin theta plus cos theta whole square. This is the form of a plus b whole square. A plus b whole square is a square plus b square plus 2ab. So we can write sin square theta plus cos square theta plus 2 sin theta cos theta. We know that sin square theta plus cos square theta is 1. So 1 plus 2 sin theta cos theta. M square is 1 plus 2 sin theta cos theta. So 2 sin theta cos theta is m square minus 1. You bring this to other side, it comes under the division. So sin theta cos theta is equal to m square minus 1 by 2. Squaring on both sides. So you have sin square theta cos square theta is equal to m square minus 1 the whole square divided by 4. Mark it as second equation. Substitute 2 in 1. This is the first equation, but you have to substitute sin square theta cos square theta is equal to m square minus 1 the whole square by 4. In the place of cos square theta sin square theta, you have to substitute m square minus 1 whole square by 4. So this becomes 1 minus 3 into m square minus 1 whole square divided by 4. Take down the LCM. 4 is the LCM. Cross multiply. So 4 minus 3 into m square minus 1 the whole square. Sixth sum. If y is equal to 2 sin alpha divided by 1 plus cos alpha plus sin alpha, then prove that 1 minus cos alpha plus sin alpha divided by 1 plus sin alpha is equal to y. Consider the given statement y is equal to 2 sin alpha divided by 1 plus cos alpha plus sin alpha. You keep the numerator as it is, 2 sin alpha divided by 1. Just interchange the two terms. So this becomes 1 plus sin alpha plus cos alpha. Then multiply the numerator and denominator by its conjugate. Its conjugate is 1 plus sin alpha minus cos alpha. 1 plus sin alpha minus cos alpha. Multiply the numerator and denominator by 1 plus sin alpha minus cos alpha, which is equal to 2 sin alpha into 1 plus sin alpha minus cos alpha divided by, the denominator is in the form of a plus b into a minus b. A plus b into a minus b. So we know that a square minus b square. So this can be written as 1 plus sine alpha whole square minus cos square alpha. You keep the numerator as it is, but in the denominator 1 plus sine alpha whole square is in the form of a plus b whole square. So this can be written as 1 plus sine square alpha plus 2 sine alpha minus cos square alpha. Then you interchange these two terms. Keep the numerator as it is, interchange these two terms, sine square alpha and minus cos square alpha, just interchange. So this becomes 2 sine alpha into 1 plus sine alpha minus cos alpha divided by 1 minus cos square alpha plus 2 sine alpha plus sine square alpha. You keep the numerator as it is. We know that 1 minus cos square theta is sine square theta. So 1 minus cos square alpha is sine square alpha, plus keep the other two terms as it is, 2 sine alpha plus sine square alpha. Keep the numerator as it is, 2 sine alpha into 1 plus sine alpha minus cos alpha divided by, then add sine square alpha plus sine square alpha, 2 sine square alpha plus sine 2 sine alpha. Keep the numerator as it is, 2 sine alpha into 1 plus sine alpha minus cos alpha divided by, but in the denominator 2 sine alpha is the common, so take outside. So this becomes 2 sine alpha into 1 plus sine alpha. Now 2 sine alpha cancel, so you have 1 plus sine alpha minus cos alpha divided by 1 plus sine alpha. Hence proved. 12th sum, eliminate theta from the equations. A secant theta minus c tan theta is equal to b, and b secant theta plus d tan theta is equal to c. Eliminate theta from the equations. A secant theta minus c tan theta is equal to b, and b secant theta plus d tan theta is equal to c. Let secant theta is equal to x. Let secant theta is equal to x and tan theta is equal to y. Let secant theta is equal to x and tan theta is equal to y. So the equation becomes ax minus cy is equal to b. Mark it as first equation. Then bx plus dy is equal to c. Mark it as second equation. Now solve the first and the second equation. Multiply the first equation into d. Multiply the first equation into d. So you have adx minus cdy is equal to bd. Mark it as third equation. Multiply the second equation into c. So you have bcx plus cdy is equal to c square. Now add 3 and 4. Add 3 and 4. If you add, y term cancel. So remaining you have adx plus bcx. Here x is common, so take outside. So you have x into ad plus bc is equal to bd plus c square. Then x is equal to bd plus c square divided by ad plus bc. Then in the place of x you have to substitute secant theta. Secant theta is equal to bd plus c square divided by ad plus bc. Then multiply the second equation into a. Multiply the second equation into a. So you have abx plus ady is equal to ac. Mark it as fifth equation. And multiply the first equation into b. So you have abx minus bcy is equal to b square. Then subtract 5 and 6. Change the sign. Change the sign. Change the sign. If you change the sign, x term cancel. So remaining you have, so this equation becomes plus. So AD plus BC into y is equal to AC minus B square. Then y is equal to AC minus B square divided by AD plus BC. We know that y is equal to tan theta. Tan theta is equal to AC minus B square divided by AD plus BC. We know that one result, secant square theta minus tan square theta is equal to 1. So in the place of secant theta you have to write BD plus C square divided by AD plus BC whole square, minus in the place of tan theta you have to write AC minus B square divided by AD plus BC. Then square tan square theta. So you have AC minus B square the whole square divided by AD plus BC the whole square is equal to 1. Take down the LCM. Here already the denominators are same, so you have AD plus BC the whole square. Keep the remaining two terms as it is. BD plus C square whole square minus AC minus B square the whole square is equal to 1. Then cross multiply. So you have BD plus C square the whole square minus AC minus B square the whole square is equal to AD plus BC the whole square. You bring this term other side, it becomes positive. So you have BD plus C square the whole square is equal to AD plus BC the whole square plus AC minus B square the whole square. Ninth sum. Prove that subdivision 1 sin 45 degree plus theta minus sin 45 degree minus theta is equal to root 2 sin theta. We want to prove sin 45 plus theta minus sin 45 minus theta is equal to root 2 minus sin theta. We know that sin A plus B. Here sin 45 plus theta is in the form of sin A plus B. The expansion of sin A plus B is sin A cos B plus cos A sin B. Then sin 45 minus theta. Sin 45 minus theta is in the form of sin A minus B. The expansion of sin A minus B is sin A cos B minus cos A sin B. Then sin 45 plus theta can be written as sin 45 cos theta plus cos 45 sin theta minus sin 45 minus theta can be written as sin 45 cos theta minus cos 45 sin theta. Multiply the minus sign inside the bracket. So you have, keep the first two terms as it is, multiply the minus sign inside the bracket. So you have minus for sin 45 cos theta plus cos 45 sin theta. Substitute the values. Sin 45 is equal to 1 by root 2. 1 by root 2 cos theta plus cos 45 is also 1 by root 2 sin theta minus 1 by root 2 cos theta plus 1 by root 2 sin theta. Plus 1 by root 2 cos theta minus 1 by root 2 cancel. 1 by root 2 cos theta cancel. So remaining you have 1 by root 2 sin theta plus 1 by root 2 sin theta. So this becomes 2 by root 2 sin theta. 2 by root 2 sin theta. 2 can be written as root 2 into root 2. Root 2 root 2 into root 2. 1 root 2 cancel. So remaining you have root 2 sin theta. Hence proved. Ninth sum. Prove that subdivision 2 sin 30 plus theta plus cos 60 plus theta is equal to cos theta. Sin 30 plus theta plus cos 60 plus theta equal to cos theta. Sin 30 plus theta is in the form of sin A plus B. The expansion of sin A plus B is sin A cos B plus cos A sin B. Cos 60 plus theta is in the form of cos A plus B. The expansion of cos A plus B is cos A cos B minus sin A sin B. Now the LHS equal to sin 30 plus theta can be written as sin 30 cos theta plus cos 30 sin theta plus cos 60 plus theta can be written as cos 60 cos 30 minus sin 60 sin theta. Sin 30 cos theta plus cos 30 sin theta plus cos 60 cos theta minus sin 60 sin theta. Substitute the values. So in the place of sin 30 we know that 1 by 2. In the place of sin 30 you have to write 1 by 2 cos theta plus in the place of cos 30 you have to write root 3 by 2 sin theta plus cos 60 equal to 1 by 2 cos theta minus in the place of sin 60 you have to write root 3 by 2 sin theta plus root 3 by 2 sin theta minus root 3 by 2 sin theta cancelled. So remaining you have 1 by 2 cos theta plus 1 by 2 cos theta. Then you will get 2 by 2 cos theta. 2 cancel, which is equal to cos theta RHS. 25th sum. If theta plus phi is equal to alpha and tan theta is equal to k tan phi, then prove that sin theta minus phi is equal to k minus 1 divided by k plus 1 sin alpha. Theta plus phi is equal to alpha and tan theta is equal to k tan phi, then prove that sin theta minus phi is equal to k minus 1 divided by k plus 1 sin alpha. Consider tan theta is equal to k tan phi. Tan theta is equal to k tan phi. You bring this tan phi other side, it comes under the division. So this becomes tan theta divided by tan phi is equal to k by 1. You have to apply componendo and dividendo rule. The componendo and dividend rule says that a by b is equal to c by d. A by b is equal to c by d gives a plus b divided by a minus b, which is equal to c plus d divided by c minus d. Now this is of the form a by b is equal to c by d. So this becomes tan theta plus tan phi divided by tan theta minus tan phi is equal to k plus 1 divided by k minus 1. Tan theta we can write sin theta by cos theta plus similarly tan phi we can write sin phi by cos phi divided by sin theta by cos theta minus sin phi by cos phi is equal to k plus 1 divided by k minus 1. Take down the LCM. The LCM is cos theta cos phi. Cos theta cos phi cross multiply sin theta sin phi plus sin phi cos theta divided by, here also you take down the LCM. Cos theta cos phi is the LCM, cross multiply sin theta cos phi minus cos theta sin phi, which is equal to k plus 1 divided by k minus 1. Here cos theta cos phi cancel. So remaining you have sin theta cos phi plus cos theta sin phi divided by sin theta cos phi minus cos theta sin phi equal to k plus 1 divided by k minus 1. Now this is of the form sin A cos B plus cos A sin B. This becomes sin theta plus phi divided by, now this is the form of sin A cos B minus cos A sin B. Sin A cos B minus cos A sin B becomes sin A minus B. So this becomes sin theta minus phi is equal to k plus 1 divided by k minus 1. We know that theta by phi is equal to alpha. Substitute. So you have sin alpha divided by sin theta minus phi equal to k plus 1 divided by k minus alpha, k minus 1. Then cross multiply. So you have k minus 1 sin alpha is equal to k plus 1 sin theta minus phi. Sin theta minus phi is equal to k minus 1 divided by k plus 1 sin alpha. Hence proved. If cos theta is equal to 1 by 2 into a plus 1 by a, show that cos 3 theta is equal to 1 by 2 into a cube plus 1 by a cube. We know that cos 3 theta is equal to 4 cos cube theta minus 3 cos theta. We know that cos 3 theta is equal to 4 cos cube theta minus 3 cos theta. Substitute the values. So you have 4 into 1 by 2 into a plus 1 by a whole cube minus 3 into 1 by 2 into a plus 1 by a, which is equal to 4 1 by 2 whole cube. 1 by 2 whole cube means 1 by 8 into a plus 1 by a whole cube minus 3 by 2 into a plus 1 by a. Then cancel the numerator and denominator by 4 tables. So you have 1 by 2 into a plus 1 by a whole cube minus 3 by 2 into a plus 1 by a. Here a plus 1 by a is common. So take outside. So you have a plus 1 by a into 1 by 2 into a plus 1 by a whole square minus 3 by 2. A plus 1 by a into 1 by 2, that is a plus 1 by a whole square. The expansion of a plus 1 by a whole square is a square plus 1 by a square plus 2 minus 3 by 2, which is equal to a plus 1 by a. Multiply 1 by 2 inside the bracket. So you have a square by 2 plus 1 by 2 a square plus 1 by 2 into 2 1 minus 3 by 2. That is equal to a plus 1 by a into a square by 2 plus 1 by 2 a square. 1 minus 3 by 2 means minus 3 by 2. Here 1 by 2 is common, so take outside. So you have 1 by 2 into a plus 1 by a, then a square plus 1 by a square minus a. Now this is of the form a plus b into a square plus b square minus ab, that is a cube plus b cube, that is a cube plus 1 by a cube. 1 by 2 into a cube plus 1 by a cube.